I will solve some questions from complex number. In this example, given w equal to minus 9 plus 3i divided by 1 minus 2i. So we have to find the modulus of w and argument w. So for this we have to find first the value of w. So for this we multiply by complex conjugate 1 plus 2i. So here 1 minus 2i, 1 plus 2i. So this will be 1 square minus I square 2 square upper 1 into this, that is minus 9 plus 3i and plus 2i से गुण multiply होगा. So 9 into 2 18 I, and this will be minus, that is I square minus, and 3 into 2 6, and this will be I square, so this will be plus. So 1 plus 4, that is 5, and upper this and this minus 15, and this will be minus 18 plus 3, that is minus 15i. So if we common 5 from here, we get this is minus 3 and this will be minus 3i. So this is the w. So modulus of w will be minus 3 square plus minus 3 square. So 2 into 3 square. So if we find it, so 3 come out, and this is the answer. And the argument value, so as we get w equal to minus 3 minus 3i, so now we find w equal to minus 3 minus 3i. So argument w can be written as argument of minus 3 minus 3i. So you have to know this is x, this is y. So in this octant x plus and y plus, in this octant x minus y plus, here x and y both minus, and here x plus y minus. So argument, for argument of x plus iy, it is tan inverse y by x, and if this xy belongs to this, so we add with this term 0, 0 will be added with this term, and when x negative and y positive, then we add plus pi with this value, and when x and y both are negative, then we minus pi with this term to get argument, and when x positive y negative, then we add 0. So in this case x and y both negative, so it will contain here. So from this we get tan inverse minus 3 minus 3, that is y by x, and as this x and y both are negative, so we add minus pi with this to get argument of w. So this is tan inverse 1 and this is minus pi. Tan inverse 1 is, that is we get tan 45, that is pi by 4 equal to 1. So tan inverse 1 equal to pi by 4, and this is minus pi. So we get 4 pi, that is minus 3 pi divided by 4. So this is the argument, minus 3 pi by 4. So you have to remember this formula. So argument is tan inverse y by x, but extra term will be added according x and y belongs this octant. When xy contained in here, so x positive y positive we add 0, x negative y positive we add plus pi, x negative y negative we add minus pi, x positive, y negative, we add 0. So in this case, x and y both are negative, so we add minus pi. So this is the answer, argument W. I'll solve another question. So this is the second example. Z equal to lambda plus 4i divided by 1 plus lambda I. Lambda belongs to set of real numbers. So given that Z is real numbers, find the possible value of lambda. So if this Z is real number, we have to find the value of lambda. So we find first Z, exact form of Z, that is lambda plus 4i divided by 1 plus lambda I. So we multiply by 1 minus lambda I, 1 minus lambda I. So from this we get 1 minus I square lambda square, that is plus lambda square. And here if we multiply by 1, so we get lambda plus 4i. And if you minus lambda I multiply with this, so we get minus lambda square I, and this will get minus 4 lambda I square, so I square equal to minus 1, so we get plus 4 lambda. So from this we get lambda 4 lambda, that is 5 lambda, and this will be plus I into 4 minus lambda square. 4 minus lambda square into I, and this will be 5 lambda. So divided by 1 plus lambda square. So from this we get 5 lambda divided by 1 plus lambda square plus I into 4 minus lambda square divided by 1 plus lambda square. So this is real Z and this is imaginary Z. So as given Z is real number, it is given. So this imaginary part will be 0, then this will be real number. So this is 0, that is 4 minus lambda square divided by 1 plus lambda square equal to 0. So this implies 4 minus lambda square equal to 0, that is lambda square equal to 4. So we get lambda equal to plus minus square root 2 or square root 4, that is 2. So we get lambda equal to plus minus 2. So this is the answer. So if you like it, please subscribe my channel. These two problems are very important for complex number. So practice it, especially for triple Bhagalpur students. Share with your friends to get benefit from this class. So thank you very much.